In this video, we're going to have a look at news regarding fusion energy, quantum computing, and some AI development. So I've used a couple of AI tools to make this one. As you can see, there's ChatGPT, so I've done a deep research run. This is an old thread I've had going for a while, keeping up to date with different developments and been feeding it different sources about different things. But yeah, this is updated from today. So I've taken this long, deep research document. It's pretty long there, you can see. I'll put a link to this, by the way, in the description if you want to have a look at it. But yeah, that's it there. I've put that into Notebook LM and then generated this video. But yeah, I won't go into too much detail here. I'll just play the video and yeah, a bit of a different format, but we'll give it a go, hey?
You know, we always think of the future as something way out there on the horizon. But what if I told you that in 2025, two of the biggest technological revolutions in history are kicking into high gear at the exact same time? We're talking about building stars on Earth and creating computers that break the rules of physics.
And, you know, it's a great question to ask, because for decades, things like fusion energy and quantum computing have been pure science fiction. Well, 2025 is the year all that changed. This stuff is officially front-page news.
And that right there, that's the whole point. We're past the point of asking if this stuff is even possible. The smartest people in the room, the top scientists, the biggest tech companies, the sharpest investors, they've moved on. Now it's all about how to do it. It's an engineering race to build the future.
So, first up, let's talk about the ultimate power source. You've probably heard the old joke, right? That clean, limitless fusion power is always 30 years away. Well, that joke just isn't funny anymore, because the race to literally build a star on Earth, it is on.
So, what even is nuclear fusion? Well, in the simplest terms, it's the total opposite of today's nuclear power plants. Instead of splitting heavy atoms apart, we're smashing light ones, like hydrogen, together. It's incredibly safe, it produces zero long-term radioactive waste, and the fuel is everywhere. I mean, this is literally the power source of the universe, and we are so close to putting it in a bottle.
And here's the cool part. There's not just one way to do it. The big one, the front runner, is called magnetic confinement. They use these unbelievably powerful magnets to trap super hot plasma in a sort of magnetic bottle. Then you've got this other wild idea, inertial confinement. It's like a tiny Death Star, blasting little fuel pellets with the most powerful lasers on the planet. And there are even hybrid ideas in the mix. So you've got this incredible global race of different approaches, all shooting for the same amazing goal.
To get a sense of just how insane the engineering is here, get this. The temperature they're aiming for inside the massive ITER reactor in France is 150 million degrees Celsius.
Yeah, you heard that right. That is more than 10 times hotter than the very core of our sun. We're talking about creating and controlling something on Earth that is way, way more extreme than the center of our own star. It's just a monumental challenge, and it's why 35 different countries are all working on it together.
But you know, this isn't just about huge government projects anymore. There is a private gold rush happening. You've got an MIT spinoff, Commonwealth Fusion Systems, signing deals worth over $1 billion with giants like Eni and Google to sell them future fusion power. Then there's Helion, who's already building a plant for Microsoft, promising them fusion power by 2028. I mean, that's just around the corner. All while other groups are proving out brand new designs and making smaller, more powerful machines.
And if you want proof, just follow the money. We're talking more than $6 billion in private investment so far. $1 billion of that poured in just in the first half of 2025.
And let's be really clear about what this means. This isn't just research and development money anymore. This is investment in building the world's first commercial power plants. The smart money isn't asking if this will work. It's betting on who's going to get there first.
Okay, so that's one massive revolution. Now let's switch gears to the second one. Because happening at the exact same time is a race to completely redefine computing as we know it. Yep, we're talking about the dawn of the quantum age.
For a while now, the name of the game in quantum has been all about one thing: qubits. These are the basic building blocks. IBM was a huge leader, breaking the 1,000-qubit barrier. But then, in 2025, this team from Harvard and MIT, working with a startup called Quera, just blew that record out of the water. They unveiled a system with over 3,000 qubits. The scale is just exploding.
But, and this is super important, it's not just about how many qubits you have. The real challenge is how good they are. Think about it like this. Would you rather have 1,000 workers who are constantly making mistakes and getting in each other's way? Or a smaller, super skilled team that works together perfectly? Companies like IonQ and Quantinium, they're all in on building that perfect, high-quality team. So you have this fascinating battle between sheer numbers and flawless performance. And check this out. This quote from IonQ really shows you what that quality means. They're talking about a system that can handle a problem space that's, get this, 268 million times larger than what other machines can do. Why? Because their high-quality qubits are just that much more effective at doing real, useful work.
And again, the market is placing its bets. $10 billion. That's the new valuation for Quantinium, one of the leaders in high-quality qubits, after they raised a huge round of funding. And that number, that's more than just a number. It's a huge vote of confidence. It tells you that investors are convinced this technology is finally moving out of the physics lab and into the real world, ready to change everything from discovering new drugs to designing financial markets. Okay, so this is where things get really, really interesting, because these two massive revolutions, they're not happening in isolation. There's this hidden engine, this whole ecosystem of other technologies that's pushing both of them forward, faster and faster.
Take high-temperature superconductors, for instance. These things are basically the secret sauce for a lot of the new fusion companies. They let you build magnets that are so much more powerful, which means you can build fusion reactors that are smaller, cheaper, and way faster to get up and running. They're an absolute game changer for making fusion a real business.
And of course, there's AI. It's creating this amazing symbiotic cycle with fusion. We use AI to simulate and control the crazy hot plasma inside the reactor. Machine learning helps us invent the new materials we need to build them. And then, down the road, all that clean fusion power, it's going to power the massive data centers that AI runs on. It's a perfect circle. Each one makes the other better.
And this support system, it's huge. You've got these monster supercomputers like Aurora running simulations for both fusion and quantum. The same kind of high-tech lasers are used to ignite fusion fuel and to control quantum qubits. That ultra-cold tech, cryogenics, it's absolutely essential for both. It's this whole web of innovation, and it's all advancing at the same time.
So, let's bring it all home. What we're seeing is not one, but two incredible revolutions happening at once. They're feeding off each other, and they've both moved past being sci-fi dreams. They are now massive, real-world engineering projects. And the speed at which this is all happening, it's just staggering. These ideas started back in the 1950s. Then we got that huge breakthrough in 2022, the first ever net energy gain from a fusion reaction. Now, in 2025, we've got huge construction at ITER and quantum computers with over 3,000 qubits. And the next step? We're looking at the first pilot plans putting actual power onto the grid in the early 2030s. Which brings us to really the biggest takeaway of all. For both of these incredible fields, we have passed a tipping point. The conversation has fundamentally shifted. Nobody's really debating if it's possible anymore. Now it's all about when we're going to see it and how we're going to roll it out. So I'll just leave you with this one last thought. What happens when these two incredible revolutions finally come together? I mean, really think about it. What does our world look like when we have limitless clean energy, powering computers that can solve problems we currently think are impossible? That is the future that's being engineered right now.
So there you go. If you haven't seen Notebook LM before, it's a pretty good tool. I've used it quite a bit, and it's good for just getting a lot of information, and you can listen to it while you're doing whatever, driving, or if you're partly preoccupied doing something else, you can absorb information that way. It's pretty useful. So this isn't about Notebook LM. I'll leave that for now. But as far as fusion, quantum, and AI go, those three feedback loops, I'm still pretty strong believing that over the next 12 months to 3 years, there's going to be some pretty significant things going on with that, and obviously ties into robotics as well. And I've got another video I've half finished regarding diffusion and robotics, and that's it's a bit of a deep dive as well. But the future I think is going to be pretty interesting. The reason I made this video is because I was talking to a friend on the weekend who was a little bit pessimistic, I guess. Maybe that's not necessarily the right term, but I was quite optimistic compared to them. So I thought I'd make this video. I was almost just going to share the Notebook LM video with them, but I thought other people might want to see this as well. I'll just put it out. see what happens. You know, might only get a few dozen views, who knows what. But yeah, it wasn't too hard to create it with these AI tools, and yeah, I've already put in a lot of effort on this ChatGPT thread. You know, yeah, as I said, that's going back maybe 12 months or something. So yeah, I'll leave it there. Yeah, I am going to do more videos, so it is worth considering subscribing if you want to do that. Yeah, I've just been really busy over the last few months, and yeah, but now I'm a bit more free time to catch up on projects that I've put on hold. So there you go. Catch you in the next video. Bye.